we go again. We're looking at, stuff, things that are said to be magic, kind of, right? Like quartz crystals. And it sure enough is magic to have quartz crystals that aren't hexagonal. Not hexagonal, is it? Not even close. It has 6 sides, kind of, sort of, not really. And it doesn't grow this way anyway, it grows this way. You know what? I don't know that now. Maybe they bang these things off of a rock inside of a hole, and so, like a geode, right? But big, and they kind of holes in rocks go along, and these things stick out of the walls sometimes, but these are really flat. And this is the growth phase. This is the side they grow on. And what crystals usually do, these kind, is they're in molten rock. Right? The rock around them was molten. They weren't like in bugs in water. There's no water at over 3,800 degrees Celsius. It can't exist. And carbon precipitates out of the melt first. And then because it's still in molten rock, right, it's kind of floating like this. It starts out small. It gets bigger and bigger and bigger and bigger and bigger and bigger. Because it's growing, and the stuff that makes the carbon is crystallizing out of the melt, and there's lots of it, right? Because it's from the semi-molten mantle down there. And if we were looking at like a model of the Earth, the core of the Earth is about the size of this little guy, and the crust is about the size of this little guy up here, this thing right here, from there, right there to there, not very much. It's about 55 kilometers deep. It might be closer to about the size of this thing, and really small. Then, right, floating on top of this thing, right, semi-molten here and here, between here and here, about 10,000 kilometers from here to here, all the way around, right? It's about 24,000 kilometers across. 30, I don't know, something like that. I've got to look it up. You can look it up. If I look it up every time, and except when I'm talking like this, I'm just like extemporaneous. If I look it up every time, I get it right every time. And so, when I'm writing it down and I'm doing calculations, then I look it up. Right now I'm talking, and I do that a lot. But that's the idea. It's the radius of the planet, basically. And most of it is semi-molten metal, and it's like a liquid, more like a waxy liquid, but a liquid, which means in metals especially that they travel around. They're not locked into crystals. They can bounce around, so it's kind of like wax. And when it starts moving upwards, it moves away from that, okay? And the reason it's semi-molten is because it's radioactive, right? Which is why these little guys kind of look brighter than than the light I'm putting in even. And that's because the carbon population in here has some carbon-14 in it. And carbon-14 gives off the mass of an electron when excited by light, especially laser light like I'm using. It reflects off the bottom of this. This is supposed to be titanium, and I'm wondering about that. I'm wondering if maybe that's one of the things they just tell people from China. China sends us these things, and if we tell people it's palladium, they go, "Oh man, how come it doesn't cost $1 bazillion?" When diamonds, right? How come it's not only, so little I gotta use magnification to see it? Well, it's because it's not from a kimberlite pipe. It's from a fault line that goes all the way to the semi-molten metal. And there's lots of carbon in there. That's what we're made out of, right? Carbon. It's not like rare at all. Not even a little bit. And most of the rock that I have out here behind me in the Sierra Estrella is silicon carbide, not silicon dioxide, silicon carbide. And it makes, actually it makes tetrahedrons, but I find like pointy crystals like this all the time. All over the ground, all over where I live. And they're light. They don't weigh very much. And that's the thing with carbon too. Doesn't weigh very much because it's just carbon, right? Carbon is lighter than aluminum. This used to be an aluminum pan, right? When it first started out, it was one of those, takeout type pans. With a little lid, in it, and the thing folds over and holds the thing in place, and it steams, and then it leaks on your way home and shit. You know the kind I mean. It's now palladium, and I've been banging it around and reusing it and smoothing it out, and it's really pretty, actually, I think. And you can reuse it over and over and over again, and you know what? It's like a non-stick surface, man. It works way better than Teflon, because you can like ruin a Teflon pan by boiling cannabis in it, because cannabis oils stick to anything, man. They stick to anything, but I made this aluminum cup into palladium by a heat process, and so now it makes rainbows on the side. You can kind of go like this, and when I blow it up, you can see rainbows in here in the kind of lines here. But this stuff, you can just wipe the canvas. It doesn't stick, man. Nothing sticks to it. I can put the whole thing full of hot coffee and hold this, and it doesn't burn me. Keeps the hot over here. Because this stuff's absorbing the heat. The AUPD absorbs the heat. I can hold this in my hand and use a torch on it. Really, the foil doesn't, it radiates the heat away so quickly, or absorbs it, right, just into it, because it's got such a high melting point. So up to the melting point, it just keeps absorbing heat, and it's so high that it just doesn't get there most of the time. Um, and so I can melt aluminum in this now. I can put my little aluminum blocks in and make it a crucible, or I can cook in it. Also, rings like a bell, which is neat. Not not at the moment, probably, because it's full of cannabis. But you get the idea. Anyway, it's nice, And these things, this rings. So you can make things with it, all kinds of things. So I was at the store yesterday playing out in the parking lot because my wife was in shopping, and I made one of these. Look at this. Back this out a little more. Maybe I can't. Okay, well, move it away a little bit. Anyway, so and it was windy, and so I had it sitting like this. I had it sitting like this out in the parking lot, and it was flying, climbing the thing, and sitting up in here, and just hauling ass. I mean, just hauling ass, because it doesn't weigh anything, right? I mean, this weighs less than one of those little whirligigs that they give kids in zoos and stuff. You know what I mean? Those things go pretty good too, but they've got a lot of resistance. This doesn't have hardly any, man. And it all just kind of works together to make it want to go around and around. And so it started going around and around every time the wind would go. And this is not AUPD. This is some other stuff that I'm playing with. And still aluminum foil. You can kind of see the difference in the color, right? But it's also a tape, so I can stick it on things, and I'm kind of playing with it to see what it does. And it works. I had just regular AUPD foil, and it worked when I was driving down the road too, right? Joe was driving, and I had this out, kind of halfway out the window, and it went round and around, really, 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 really fast until until the little piece of tinfoil finally gave up the ghost, because the one that was whole stayed perfect. The one that I had kind of tried to piece together up here it came apart. It was the only foil I had with me in the store parking lot. So, you can make anything with it. And you know what this is? This is a spoon. I can put a little piece of foil here and eat with it, huh? Right? Or spoon sugar into my coffee or whatever. It's a spoon. And when I'm done with it, I don't have to wash the whole damn thing. I just wash the little piece of foil. Right? And nothing sticks to it, man. Nothing sticks to it. So it's real easy to wash the little piece of foil. And germs don't stick to it either, right? It's nice. It's nice. You don't have to worry about it getting funky, right? Which is cool. Okay, so, and then you can turn it around. And then I've got two of them actually, and I kind of misplaced the other one. I was swatting flies, and it went flying. But it makes chopsticks. Right? chopsticks. It makes money. Right? We can use it for money because you can count how many centimeters long your thing is. Okay? By how many twists it has. This is 3 millimeters. This is worth about, I don't know, 25 cents, something like that. Maybe less, 2.5 cents. Anyway, the supply and demand has a lot to do with that, not how many pictures of presidents we have. It's how much people need something, right? A commodity, and what they can do with it. What they can do with it. With this, I can sharpen the points kind of a little bit, and then I have a fork for escargot. You know how hard it is to get those little buggers out of the shell without one of these. So hey, and 2 of them too, right? 2 of them. And when you're sitting in parking lots and stuff, you can do things like make whirligigs. And you can make useful stuff too. Because you know what this is? See, you know what a gyrocopter is? Gyrocopters have like a propeller on the top, like a helicopter, but they're not driven, right? They're not driven by a motor. The motor's in back and it's pushing, right? There's a little, propeller like a regular airplane propeller, pushing it forward. And they have to go forward, and as it goes forward, it starts catching the wind. And this thing going round and round acts as a wing, and it gives it lift. Okay? So that's what I was playing with here, right? Because I want to make spheres fly. Right? I want to have a sphere that flies and won't fall out of the sky. But you know what, man? You can't foresee every situation. You just can't. And so if my family's up there, I don't want to go, whoops, I didn't think of that. You know what I mean? And this is like it's too late then, right? So what we're going to do is have a gyrocopter thing on the top of it, right? So that as it's falling, it'll just, sit there and moosh down when it's moving forward this way or, kind of that way, right? And it's wired to, so that it's like kind of spring-loaded. But if it starts falling, the wind's going to catch it, boop, and take it out. And it becomes a parachute, and it drops the people we love to the ground about as quick as your average leaf falls from a tree. Because I love people, man. I don't like people falling out of the sky. So I was playing with an idea with this stuff. And you can build all kinds of useful things, that you don't have to buy from somebody else and that don't break. Right? These little aluminum pans will break right away, man. You bend it a couple of times and it breaks. You know that, right? I bend this thing and rebend it and bend it back, and I rebend these all the time, man, like this, all the time, and I use them for, holding things together, right? It's now something to hold things, and I can make things with it. I can make bicycle frames. I can make the frames for my dirigible. There it is, right there, folks. That's all I need. And I can reuse it if my dirigible gets old and I want to build something else. I can reuse it over and over and over and over again because it doesn't rust and it doesn't go away. It weighs, this weighs the same weight as a pair of bamboo chopsticks. It is possible to put palladium, this stuff right here, in 3% hydrogen peroxide, which is 97% water. And it turns the water into hydrogen peroxide. It turns your hydrogen peroxide, it'll bump it up to about 35%, over time. 35%, I think, is about the maximum solution for that. But I don't know that it's gonna be, take it up that much. I think they maybe have to boil off the water to get that kind of concentration. But you know what? I don't know, man. But I will find out, and we'll make hydrogen peroxide this week. And you know what I'm gonna do? I'm gonna put it in a little test tube, drop some of my palladium in, and put a balloon on top. And we'll watch it and see if it blows up. And I'll put another test tube, right? You use a control, so that it's just got no palladium in it, just the hydrogen peroxide, even though they bubbles, right? And so maybe that's what's blowing it up, and I don't know. So I'll have one of those. And we're going to see if we can make my spheres and my balloons fly with hydrogen peroxide as the fuel. Because when you burn hydrogen and oxygen, what you get is water. You don't get any pollution, you don't get any bullshit. Water. From palladium. Pretty close to magic, you guys.